So I'm going to start uploading videos of the different lessons that I'm going to teach you. This here is Chapter 5, Modeling Graphs, and you'll find the videos, of course, in the content section and in the announcement section. Okay, so we're going to look at, and you're going to find a completed copy of this lesson in the content section. So we're going to be looking at sections 5.1 and 5.2, direct versus partial variation, and it'll make more sense once we look at a couple of application examples. So we've got two math tutors. We've got Holly and Anna. Holly's going to charge $20 an hour. Anna has a different pay structure. What she's going to do is she's going to charge $10 to come to your house, and then every hour she's there, she's going to charge you $15. So let's look at Holly, who charges $20 an hour. So the first thing we're going to do is we're going to complete a table of values for Holly. Then we're going to take this data and we're going to graph it. Okay, so just like with scatter plots, the first column here is the independent variable, which would go on the x-axis. The second column here is the dependent variable, and it goes on the y-axis. Okay. So when you think about how much you pay your math tutor, how much you're going to pay them, the cost really depends on how long the tutor was there. So that's why cost is the dependent variable. Okay, so I've done a couple of hours here. She doesn't come 0 hours, 1 hour, 2 hours, and 3 hours. Okay, so I know Holly charges $20 an hour. So I know, and then you can, just do this in your head or on your calculator. You're going to take $20, times it by the number of hours, which is 0. So if she doesn't come, you don't pay her. You owe her $0. She came for 1 hour. You times it, $20, 2 hours, $40, and then 3 hours, $60. Now we're going to graph this here. Okay, now when I do my grid, I notice I have no negatives here, so I wouldn't include the negative quadrant. So everything is just going to be positive. So this is going to be my time, and this is what you need to label. You need to label this axis that it's time, and then you got to tell me what time is in. It's in hours. It's not in minutes. It's not in seconds. It's not in years. It's in hours. So you write it. Okay. So then here is my cost. Again, I'm going to write down here that this is my cost. Again, this is in dollars. Now I need to decide when I graph what scale I'm going to go by and how much space I'm going to leave. Okay, so this is what you decide, right? You decide the spacing, and you have to be consistent with your spacing. So if I'm going to start here at 0 and I decide to leave 2 spaces, like 1, 2, I always leave 2, 1, 2. Okay. You can't start off going by 1 space and then going by 2. You have to have consistency with your spacing and with your scale. So I'm going to go by ones. Now I look here and I decide what spacing do I want to go by and what scale. So I'm just going to look at what I got here, and I'm going to probably go by 20s, and I'll probably go by 2 spaces again. But again, these are decisions you're going to make. Okay. You have to give your graph a title. It doesn't have to be fancy. I just usually take what's here versus what's here. So I say cost versus time. So I usually do all my labeling first. Okay. Now I start plotting it. So I got 0, 0, 1 hour, 20, 2 hours, 40, 3 hours, 60. This is not a scatter plot. This is a line. You must connect your points with a ruler. You don't use a ruler. It's not straight. You don't get full marks. You don't connect your points, you don't get full marks. You need to connect them. Oops, it should be like that. Okay, so there's my line. Okay. And then, so I've done my table and I've graphed it. So what's important here is writing an equation that's going to model this. Okay, so I'm going to let certain variables represent things. So you're going to have to get into the habit of introducing your variables. So I'm going to let C represent the cost of tutoring, which is my dependent variable, and I'm going to call, let's say, N the number of hours. Okay, whenever I write an equation, I always start off with the dependent variable equaling It's going to equal. So here, my dependent variable is my cost. Now I got to see how, let's look here to look at our equation. Hopefully you notice that each of these hours is being multiplied by the same number, which is 20. Okay, later on we're going to call that a slope, but this is what's common in with the number of hours. So we're going to call that, so it's 20, and then the number of hours is n, and there is my equation, which makes sense because I actually had it here, right? This is my number of hours, which is n, and it equaled my cost, which is here. Okay, now let's look at Anna. Okay, we're going to do the same thing. We're going to do the table of values, and then we're going to graph it, and then we're going to come up with an equation. So let's go back and read what Anna does. Anna's going to charge you $10 to come to the house, and then every hour it's 15. Okay, so you've scheduled Anna to come, but you weren't home, right? So she $15 every hour, 0 hours, but she came to your house. How much money do you owe her? 15 times 0? 0 plus the $10. You still got to pay her the $10 for showing up. Okay, so now Anna's there for an hour. Okay, to follow your order of operations, 15 times 1, $15, plus the $10 to show up to the house, 25. Okay, so 15 times 2 plus the $10, so 15 times 2, $30, plus the $10 to show up, and then the last one. 15 times 3, 45, plus the $10 to show up, 55. There's my table. Now once again I'm going to graph it, do the same thing I did before. Here's my time, hours. Again, my cost, which is in dollars. Again, I always give a title, cost versus time. And then here, once again, I decide what scale am I going to go by and how much space. So I'm going to go again by ones, and I'm going to again go by a scale of, scale of ones and spacing of 2. Okay, you don't have to go by a spacing of 2, whatever you decide. Okay, and then I'm going to here decide what do I want to go by here. So maybe I'm going to go by, I don't know, tens. And I'm going to go this time by maybe a space of 1. So again, these are things you decide, right? So 0, 10, 1, 25, 2, 40, 3, and 55. Once again, this is not a scatter plot, it's a line. You need to connect this line with a ruler. Okay, just like that. Okay, if you find when you're doing the work that your graph is not a line, it starts to curve, it starts to zigzag, it's a clue that you're making a mistake. Okay, so these are going to be lines. So there's the data, there's the graph. Now we're going to write an equation. Okay, so now we're going to write an equation that models this. So once again, we always start with the dependent variable equaling. So the cost, we'll use the same thing. We'll call this C and this N. So cost equals, so now let's look here. This is going to help us come up with the equation. So let's see what's happening. If you notice, this is always the same because it's $15 every hour. The time is changing, right? And again, this is the same, the 10. So I know the 0, the 1, the 2, and the 3, that was N. So that's 15 times N, the number of hours, plus 10. Okay, so $15 every hour plus 10. So we call this here, it's called several things in this chapter. Sometimes it's called the fixed amount. Okay, which means that it's not changing. She's just, every time she comes over, she's going to charge you $10. This is a variable amount. This here is a variable term because it has a variable with it. Okay, and we're going to get into more detail with what this 15 is called later on and what this 10 is called. Okay, so the dependent variable is always starting, so it's like y. This here we'll call, well, again, when we get more into chapter 5, you'll see how to calculate this. This is called a slope. We call it m. And this here is our dependent variable, or sorry, our independent variable is n. Okay, and then b is our fixed amount. So this is dependent. This is our slope. This is our independent variable. Okay, and this here is actually right here. It's the intercept where it intersects this axis right here, which is the y-axis. So later on we're going to call that the y-intercept. Okay, or the constant or the fixed amount. So there's lots of terminology used for this b value. Okay, but you'll notice that the b value is right here at 10. So let's go back to Holly for a moment. Let's look at her b value. It's right here. It's at 0. So I can write this also in the form y equals mx plus b. But this is y equals m, which is our slope, x, which is our independent variable. But what's b this time? B is 0. I'm not going to write plus 0. I'm just going to leave it like this, y equals mx. Okay? So here, my b value is 0, so I don't write plus b. I don't write plus 0. Here, my b value is a number other than 0, so I have to include it. So I have to include that plus 10. Okay? Now, Holly, let's go back to Holly. Her graph and her equation is called a direct variation. Direct variations, the line goes through this point right here, which is 0, 0. This is called an origin. Okay, so a direct variation is a line that goes through the origin, and the equation is in the form y equals mx, because the b value is 0 and we don't write plus 0. Now Anna's is an example of what's called a partial variation. Okay, her graph does not go through 0, 0, does not go through the origin, and she's got a b value that does not equal 0, which we have to include. Okay, so let's just summarize that. Holly's situation is an example of a direct variation. The line goes through the origin. Remember, origin is 0, 0. The equation is in the form y equals mx. Okay? Oh, sorry. Anna is an example of a partial variation. The line does not go through the origin. Remember, the origin is 0, 0. The line starts at a number that is not 0. The equation is in the form y equals mx plus b. So they both have the y, they both have the m, they both have the x, but there's a number other than 0 here. And that's it.